Yes, yeah, let's look at some calculator ones. Okay, what about one of these? Okay, so what are our options here? Okay, girls, everybody up here, please. What are our options here?
Is this non-graphing or?
This is, okay, if it's non-graphing, it's pretty hard. I'm not going to probably give you one of these to do non-graphing on the test, just because it takes too long to do. So, assuming we have a graphing calculator, what are our options here?
Press that.
Okay, so we could just use quadratic regression. Agreed?
See.
In this case, that's a pretty good idea, because look at the instructions that were given. Okay, the instructions specifically say that we can, I'll make that maybe just a little bit bigger. They say that we can round any numbers to the nearest thousandth. Okay? So we can, now if we use quadratic regression, the calculator is going to give us back, remember. Do we want to go through that? Do you guys need to see that, or we'll look at that once? Okay, so if we go through this and do quadratic regression, right, that's where we just go stat edit. Okay, here's where we just need to put in all the ordered pairs. Now I'm not, oh, that one, I guess we just, the parentheses got cut off, but it's supposed to be a point also, right?
I don't know what.
Okay, I don't feel like I have everybody's undivided attention, and a couple people whose undivided attention I don't have are missing lots of stuff, so let's make sure we get the focused up here, please. Okay, so let's see now. I'm going to put in those 3 point. This is a different function, okay, but it doesn't even matter. I mean, this isn't going to be the answer, but pretend it is, just so I can speed this up a little bit. Once I get those 3 ordered pairs in there, right, x column, y column, just like it was for linear regression, then if I just go stat, calc, what option? 5, yeah. Stat, calc 5, and you're going to get that, right, you're going to get that different look here than I do, because mine's kind of old and tired, but that's what it looks like. It's telling us for the quadratic function of the form y equals ax squared plus bx plus c, those are the coordinates, or the coefficients, sorry. Now, if you get one where those are decimals, that's okay, because this question is kind of giving you license to use that technique. It says you can round these anyway. Now, what if you needed exact answers for the coefficients? What would you do instead? Instead of regression, what's the other option? You remember? Yeah, we could turn this into a linear system, right? Because we have, so the other option would be, if we fit these to standard form, y equals ax squared plus bx plus c, or general form, whichever one you want to call it. Each of these points is going to give us back a unique linear equation for a and b and c, right? If I plug in, for example, if I plug in -7 for x and -6 for y, what am I going to get? Well, my y value is going to be -6. What am I going to get for the first term? A times what number squared? -7, right? So -7 squared would be 49. So for the first one, I'm just going to get 49a, and then plus -7 times b, so -7 B plus C, right? If I just move the constant to the other side, that looks like standard form, doesn't it, right? So I'm gonna get an equation like that for each of those ordered pairs, right? Second one would just look like when x is -4, y is 4. So 4 equals 16, right? -4 squared a, right? Minus 4b plus c, right? And then the last one, -2 equals 9, good, 9a minus 3b plus c. Make a linear system out of it, right? So if I move all these numbers over to the other side, then that looks an awful lot like what we did before. I can just make a 3x4 linear system, ask the calculator to put it in reduced row echelon form, and it gives me the answers.
How do you do that last one with the calculator?
So, okay, so with calculator then, let's just do this. Whoops, let's just do this part. So, with calculator, we can just go second, matrix, edit, A, 3x4. So what are the coefficients going to be in the first row of ours?
49.
Okay, good. 49, -7, right? If I'm doing the first row.
You're making a really big one.
Oh, whoops. That's probably not what we want. It's a big matrix. Okay, so 49, -7, 1, and then the constant has to go in the last column. So -6. Okay, 16, -4, 1, 4, 9, -3, 1, -2. Good.
So
There's our matrix,
You don't
right?
have to do like the opposite symbol for the y's. Like you don't have to change it to 6, -4, and 2.
No, because, see, these are set equal. So for example, for this first equation, all I need to do to put this first one into standard form would just be to push the constant over there. So it's 49a minus 7b plus c equals -6. Right, because remember that when we write the linear equations in standard form, we just have to write the variable terms in alphabetical order equals the constant, okay? And so then if I just finish that up, if I just quit and I go back to remember this stuff, go back to matrix, math, scoot up to RREF. So put it in reduced row echelon form, matrix, A. So there are my answers, right, for this one. But instead of being in decimal form, okay, which it turns out this one, we didn't actually put the data in for this one. If I had put the data in, I would have gotten decimal coefficients. If we needed exact coefficients now, I can just go math, convert to fraction, and it gives me the coefficients as exact answers. Okay? Make sense? There are limits to our calculator's ability to do that. They're not going to resolve these into square roots or things like that. But like the TI-89 would, they would give you exact answers even if they weren't fractional. If they were irrational, it would still give them to you. And so would, in college, you'll probably use, we don't quite have the moolah in the district to put the bill for this, but you'll probably use fancy computer algebra systems like, well, MathCAD's not really, but probably like Maple or Mathematica in your math classes, where you'll have a computer that does this kind of stuff for you and even does it better than a TI-89 would. It'll give you back exact solutions. okay? Wish we had a few of those available to get you a little hands-on with that, but maybe by the time you're seniors you will, you never know. So, anyway, questions on that? Does that make sense? Okay, I think that's it. I think we covered pretty much everything. We went through, we've obviously done quadratic formula with decimals, right? So I think we're good to go.